Okay, here are problems, homework problems 9 and 10. Now, number 9 says Simon counted the number of red trucks in each section of the parking lot at the mall. I would say that this is not a graph that is a function, a typical function like this one, but more of a discrete type of graph where we need to think about the section of the mall. So X is going to represent, now it's not going to represent a quantity. In this case, it's going to represent a section of the parking lot at the mall. Section of parking lot at the mall. So we'll number the sections, maybe section number 1, section number 2, section number 3, section number 4, 5, 6, and 7. And then Y is going to stand for the number of red trucks. The number of red trucks in that section. So Simon's in section 1, and we'll just maybe say 1, 2, 3, 4, 5, 6, 7. It's not a busy time at the mall, but busy enough that we might be able to get up to 7 red trucks in any given section of the mall. And these numbers are arbitrary. You can make up the numbers you want. You can pretend that this is a super huge mall. It's in the middle of holiday shopping. It is packed to the limit, and you can make these go up by 5s. Maybe you're going to pretend that there's hundreds of red trucks in a parking lot. You can use these numbers whatever you want, but it's about what the graph looks like. So for instance, on the last graph, it was about having that break in the graph. That was probably the most important thing, that you read, take a break, and then read, okay? This one is going to be discrete because we can't have a portion of a red truck. It's either a red truck or it's not a red truck. So in section 1, we'll pretend that we counted 3 red trucks. Okay? And in section 2, we'll pretend that Simon counted 6 red trucks. And then in section 3, maybe he counted 2 red trucks. And then in section 4, maybe 0 red trucks. And in section 5, 1 red truck. And in section 6, 4 red trucks. And in section 7, 6 red trucks again. That would be considered a discrete graph. And that's the most important part of this exercise. This is discrete, whereas number 8 is going to be a continuous graph because we've connected the points. So this is continuous and this is continuous. Nothing about this second graph is continuous at all. We're not going to connect any of the dots. On number 10, take a minute to think now, am I going to have a continuous graph or a discrete graph? On Monday, the furniture truck made 3 deliveries within 8 miles of the warehouse. 3 deliveries within 8 miles of the warehouse. So, this reminds me of a problem that we did in our notes. I'm going to say that X is the time, the number of, we'll say the number of hours. The number of hours spent delivering furniture. And Y is going to represent the number of miles from the warehouse after X hours. So 0 time, 0 hours spent delivering furniture, 0 miles from the warehouse. But now time is going to go on, and what's going to happen? Time is going to pass, and we're going to make a delivery. So maybe this much time has passed, and then we're making a delivery, and our number of miles isn't changing, but we're still delivering the furniture. So the truck is driving to the first delivery, and then the number of miles is staying stable because we're still delivering. And we'll say this is 1, 2, 3, 4, 5, 6, 7, 8. And it's all within 8 miles. So then they go to the second delivery, and I'm going to say the second delivery is going to be maybe up here. So they go to the second delivery right there. That one's 8 miles away. Then they're going to come back down to maybe they're going to spend some time delivering. I think I went over a little bit too far, and that's where we're going to use our eraser. So we're going to put here, there's our 8 right there. Okay, there, I think I went a little bit too far. So there's our 8 miles, and then they spend some time actually delivering the furniture. And then I'm going to say they came down here. That's the third delivery, so they spend some time at that third delivery, and then they come back to the warehouse. So maybe this is the entire time they spent making their deliveries. So this right here is delivery 1, this is delivery 2, and this is delivery 3. We connected these dots. This is a continuous graph. I say dots, they're really points, but I like saying connect the dots. This is a continuous graph because as time passes, we'll just say that that's 2 hours, 3 hours, 4, 5, 6, 7, 8. As time passes, our distance from the warehouse is increasing. Our distance is staying, but we're still delivering. And then we start moving again. Moving means time passes, distance increases, but then distance doesn't change because we're delivering. Head back, delivering, and then head back. And there's your number 8, 9, and 10. I hope that helped relieve a little bit of your stress. If you got to these problems and you were like, I'm not quite sure what I'm supposed to do,